Uh, are you able to see my screen as well?
Sorry?
Are you able to see my screen?
Yes.
Good.
Yes.
Well, thank you. Hello all. This is Roy. Today I'm going to present my research on nanoscale study of the influence of short-term and long-term aging on asphalt binders properties. And this research is supervised by Dr. Zaid Hussain, Associate Professor of Civil Engineering at Asphalt. So here, as you know, the asphalt binders experiences different kind of aging during its service period in the field. Sorry. Hello?
Yeah, we can see your screen. You can continue.
Well, as you know, that asphalt binders experiences different kind of aging during the field conditions, and that time it becomes stiffer and brittle, which leads to asphalt hardening and reduces the service life of the pavement. However, it is also found that aging can influence in developing of different kind of pavement distresses, including fatigue and thermal cracking. Here you can see in the picture, the left bottom is on fatigue cracking, and the right one is thermal cracking. However, it is also found that aging can change the rheological and mechanical as well as the chemical properties of the asphalt binders as well. So thus the major objectives of our study are to evaluate the aging effect on asphalt binders, morphological and mechanical properties at micro and macro level. Finally, recommend the suitable asphalt binders for durable pavement construction. In this study, 4 types of asphalt binder are used and evaluated in the laboratory, and these binders are collected from 2 different sources. In this study, we use the performance grade PG64-22 binder as a control, because this binder is widely used in the area of Arkansas, and the suppliers are certified by Arkansas Department of Transportations. We also use the control binders along with its modified counterparts, and the binders are modified with polyphosphoric acid, styrene, butadiene, styrene, and the combination of both PP and SBS. In this study, we used an advanced technology for nanoscale measurement. We used atomic force microscope to observe the asphalt binders micro mechanical properties along with its microscopic surface roughness. And we use the peak force quantitative nanomechanical mapping mode of FM, where the scan area was used like 10 micrometer by 10 micrometer. Here you can see some typical FM based map of height, which is roughness, DMT modulus, and addition value. So the micro level FM test result shows that all unused asphalt binders, we found 3 distinct phases, which are called dispersed or catena, interstitial or free, and matrix or perpetua. However, these phases were significantly changes or disappeared or reformed in case of short-term and long-term aging. Here you can see in the picture a typical FM-based map was shown of a source on asphalt binders. Also, the V-like structures were significantly changed or reformed due to the aging of the asphalt binders. In this table, I summarized the DMT modulus and addition force values obtained from FM, and along with their average value, I calculated the aging indexes to compare and show the changes and the severity of aging effect on the DMT modulo and addition forces value. The result shows that here the red circle is the most severe one, and here you can see like a control binder from both sources had the highest increment in both modulus and addition force values, whereas the SBS and PPA plus modified asphalt binder had the least increment. However, there is a trend among all of the asphalt binders that regardless of their aging conditions and binder type, the DMT modulus and adhesion force values are increased due to both short-term and long-term aging. Here, the macro level rotational viscometer and dynamic shear rheometer tests were presented. Test results that are presented along with their aging indices. Based on the RV test results, it has been found that the S1 binder had the higher viscosity. That means the S1 binders were more stiffer than their corresponding S2 binders. And these findings are in correspondence with TRC 1501 project final report. However, the DSR test results found that the PPA plus SBS modified binder showed the minimum increment in rating factor, while the control binder showed the maximum increment in their rating factor. So finally, based on the RV and DSR test results, it can be said that in case of asphalt binders, regardless of aging condition or binder types, it is found that asphalt binder becomes stiffer at all the time with the increment of their aging condition, and the FM result shows that the binder surface toughness is significantly changes due to aging, which may affect its mechanical properties. Moreover, the DMT modulus values were significantly increased due to the concentration of polar matrix increment during the aging condition that leads to developing the asphalt hardening. Also, the adhesion force increased due to the aging effect. Moreover, the aging indices showed that the base binder, which is expected to experience premature fatigue distresses than the modified binder evaluated in this study. Finally, it can be recommended that the base binder modified with SBS alone or with PPA can be used for durable pavement constructions. I would like to acknowledge Tran-SET for funding support of this project, also NSF, Arkansas Department of Transportation, the ORT at Arkansas State, Ergon Asphalt and Emulsion Inc., Paragon Technical Services, and other suppliers of the test materials for this project. Here are some references that I used in this study. And I would like to thank you all faculty and staff, students, those who are involved with happening this conference successfully. Thank you all. I would be happy to answer the questions.
Thank you, Saman. Thank you very much for the presentation. Any question from the attendees? You can always unmute and ask the question if you want. So if there is any question, you can